We are back with more Excel, looking at how to make histograms in this video. But before we do that, in the last video, I wanted to emphasize something about box plots here in terms of statistics and the content that we're learning. So I talked about how the range of usual values that we find typically with IQRs is Q3, where we add 1.5 IQRs to find the maximum or like the upper bound for that range of usual values. And then we take Q1 and subtract 1.5 IQRs to find that lower bound for that range of usual values. So I wanted to go ahead and actually calculate these to verify with you visually that that's what this box plot did. So the minimum value here, again, would be if we took Q1. So we can go click on Q1 and we subtract 1.5 times our IQR. So remember we calculated the IQR earlier. I want to point out too here, when we write mathematics, sometimes we use parentheses or things like that to indicate multiplication. Excel is very particular about that. Excel has to have a multiplication sign or this star to indicate multiplying. If you tried to do something like this, it gets mad at you. Notice there what it did was it suggested you added that asterisk to say multiply. Okay, but we're not trying to multiply by 70. We are trying to multiply by our IQR. So right now, this minimum range of usual values, we're finding Q1 minus 1.5 times the IQR. Okay, we get negative 306. So remember I told you over here, this bar indicates Q0. The reason why this bar indicates Q0 and this one does not is because the lower bound of our range of usual values was below our minimum guess. So this basically defaults to be Q0 or the minimum. Okay, to find the maximum for that range of usual values, we take Q3 and we add 1.5 IQRs. So again, that's Q3 plus 1.5 times this number. And this is what we get. So this value, again, is saying the upper bound of our range of usual values is, I'm going to round, about 1,092. So any guess outside of this range from negative 306, which is not a possible guess, to 1,000, about 93 is considered, anything within that range is considered usual. So what happens on a box plot is they use that range for these whiskers if you have values outside of that range. So then Q4, the maximum, pops up here. But notice that this value is around where I would guess 1,093 would be around here. So that's what it was calculating. Okay, that was kind of a separate point, but I just wanted to point that out. All right, we're going to come over into sheet 3 now. I'm going to copy our data again, go to sheet 3. And on this sheet, we are going to be looking at histograms. So I'm going to remove here. Excel's awesome with histograms. So if we highlight all of our data, again, so far in our course, we've been learning how to make histograms by hand. In fact, on the very first sheet in this Excel file, we made a relative frequency table, and we use those to make histograms. But here, Excel does this really quickly for us. So if we highlight all of our data, we can go to Insert. So we looked at this earlier, and then Charts. So this chart brings up a lot of options. I'm going to click down here. Again, I like the list to help me see kind of what I'm clicking. So I'm going to go to Histogram. And notice here, it already kind of gives you an idea of what this looks like. So I'm going to hit OK. All right. Chart title. I'm going to change this to candy corn guesses. All right. Okay. Format axis, format major grid lines, add minor grid lines. There are a lot of things we can do here. I'm going to go to format axis and notice that's already popped up over here. So you can change the scale here. You can change if there are units displayed. You can also, for example, add labels. So to help you label axes, which is very helpful when we're working with things. So I'm going to do that later on, but I just want to show you a lot of kind of what's going on here in this video. I don't want to make it too long. So one thing we can also do over here in the formatting area, notice right now, so bin width, bin width, width, bin width is the width of the intervals that we see on histograms. So for example here, the bin width is 410 minus 120, which I can't do it that quickly in my head, but guess what Excel can do? 410 minus 120. So our bin width right now is currently 290. Excel naturally finds this on its own to display it in a certain way, but what I want to show you is how to do this in another way. So we can take this and display it with this bin width that they naturally give us. What we can also do is click down here, and again, if you weren't already in the format axis area, you can go to format axis. And then if we click over here on the, I'll say the graphing area, axis options, notice it gives us bin width, number of bins, things like this. I'm going to go to bin width, and instead of 290, I'm going to play around with this. So when we made our relative frequency table, we made a bin width, or our intervals, we made 100. So before I even do this, I'm going to go remind us what that looked like. So over here we made our relative frequency chart. And if you recall, for example, 9 guesses were between 100 and 199. So this interval we made, you could think of as a bin, and so this interval of 100 to 199 has a bin width of 100. And each of these, so when we make histograms or when we make grouped relative frequency tables, we do want even intervals usually to help us look at the data. Okay, coming back over to histogram. Coming back into format axis, bin width. So I'm going to change this to 100, and it should display the data fairly similar, except that it's going to start at 120 instead of 100. Ours started at 100. So theirs, I think, will probably start at 120. Okay, I'm going to change this to 100. Yep, okay. So theirs started at 120 to 220, and then 220 to 320. I'm going to point out some notation on this page that's very important in mathematics and statistics with intervals. So notice these, for example, this one uses an open parentheses and then says 320, comma, 420, and then it has a closed parentheses. What this means, this open parentheses means we do not want to actually count 320 in this. So we're starting, if someone had guessed, which is not a guess in this data set, but if someone had guessed 320.000001, they would go into this interval. But if they guess 320, they don't go into this interval. If they guess 320, they would go into the interval before it. And that's what that closed bracket. So the closed parentheses or closed bracket means include that value. So if someone guessed exactly 420, they would fall into this interval because of that closed bracket. So again, if someone guessed 320, they would fall into this interval because that's where that closed bracket is for that 320. Okay, going back to our histogram. So showing you how changing bin width can change the way that this looks. So we've looked at skewness of data and noticed that this looks very skewed right. So this tail over here kind of pulls data to the right. So this data looks very skewed right. And we have the majority of our data is kind of towards the left in these lower values. So this is kind of starting to analyze the shape of our data. But again, I want to point out that if we change our bin width here, let's change it to 50. This looks a little bit different now. We get a little bit more detail as to what's going on over in these intervals. So again, the majority of our data was over here. So if I go back to 100, we don't really see as many details going on because so much of the data is grouped in this way. So if we go to 50, check that out. We find out that there was only one guess between 370 and 420. But if we go back to 100 as the bin width, we don't see that. We wouldn't know that. because that one guess is in this bar somewhere, and we can't, you know, pick out that, oops, down here. Yeah, we can't pick out that specific value. So let's look at 50 bin width. Let's look at 25. Woo! Now we get even more information. Look at this. The most number of people guessed between 120 and 145. Isn't that interesting? But if we went back to, let's say, 100, we can see that the majority of the, or sorry, not the majority, the most people guessed between 120 and 220, but that doesn't tell us, like, 100 is a pretty large interval. So anyway, looking at how these, I should say, changing the bin width can change the way we see the data. Like, what if I made this 500? Now we lose a lot of information here, right? Okay. Just wanted to kind of walk through that, show you how kind of different bin widths affect the way that your data appears and the way that we can actually analyze the data. I'm going to change this back to like 30 because I think this is a pretty interesting. Notice like the 7 people guessed between 120 and 150, but 5 people guessed in this range. It's not showing up here because of the size, but how interesting. This is kind of almost a bimodal data set. So we have like 2 values that have the highest, not tied modes, but they have higher modes than the rest of the data. Okay. Or I should say they have higher frequencies than the rest of the data, not higher modes. Okay. All right, I'm going to pause here. And then, yeah, this is, I think, where I want to stop for now in this data. And then in the next video, we're going to find mean, median, mode, things like that to analyze this data in a totally different way. All right, thank you.